2, Lesson 1, Describing Distribution. All right, so the first one that we're going to be doing is called How Did Marty Do on His Test? Oh, nope. Yes, sorry. We're on the right lesson. I apologize. Okay, so the first thing you're going to do is it gives you what you're going to do on your own without looking at my answers, of course, and then you can discuss this, is it gives you this data, and it says the mean of this data is 80 and the standard deviation is 10. Then it says Biff scored 60 on his quiz. What's the percentage of the scores that's less than 60? So nothing's less than 60, so 0 out of 20, which is 0%. So Marty scored a 90 on the quiz, and so what percentage are less than 90? So you would count them all up, and 16 of them, 16 out of 20, which is 80%. Really, honestly, I'm going to say this is what the publisher has, but really I think it should be 17 out of 20, which is 85%, because really it should be less than or equal to. So that's really what I prefer for you to have written on here. But right now that's what we've got here. But from future on, you're going to put less than or equal to. Okay, let's look at number 2. How far away from the mean is Biff's score of 60 and in what direction? So I'm going to do the observed value of 60 minus the mean, which is 80. 60 minus 80 is negative 20. And that's 20 below. So how many standard deviations is that? Well, guys, if a standard deviation that it gave you is 10, and one standard deviation is 10 points, basically. So how many 10s can I fit into 20? And that's 2 of them, and I find that by dividing. Basically what I'm doing is I'm converting euros to dollars. And so that's what's going on here. So I have -2, because that means that's 2 standard deviations below the mean right here. And that is called a z-score. A z-score is how many standard deviations I have. And if it's negative, it's below the mean. If it's positive, it's above the mean. Z-scores are available in order to compare your data. Because, for instance, you don't know how you did on your SAT test. You don't know how you did on your ACT test. So I'm going to show you just one quick example. Okay, let me just show you one quick example here. So if a boy is 60 inches and a girl, let me say 70 inches, so 5'10", and a girl is also 70 inches, the mean of boys is actually 70 inches, and the mean of girls is actually 64 inches. And the standard deviation is 2.5 inches, and same thing here. So a boy's z-score, remember how many standard deviations it's away from the mean, is 70 minus 70 equals 2.5, 0. A girl's z-score is 70 minus 64 over 2.5, which is 6 over 2.5, which you can see clearly is greater than 0. The boy is not considered tall, but the girl is, because the boy is comparing himself to other people of his same type. The girl is comparing herself to other people of her same type, and so therefore she is considered tall compared to most girls. The boy is not considered tall to most boys. So by able to be comparing z-scores, that is the way that we can compare things that are not the same to see which one is better in their category. So that's the purpose of z-scores. So for number 3, how far is the mean of Marty's score of 90 and in what direction? He's 10 above, so 90 minus 80 is equal to 10, which is 1 standard deviation also, because 10 divided by 10. So 97, we're going to do 97 minus 80 is equal to 17, and of course that's 1.7 standard deviations above the mean, because 17 divided by 10 is 1.7, so the z-score is 1.7. So the z-score formula is score minus mean divided by standard deviation. And you're going to have the psychology test. We don't know the mean and standard deviation here. We just know that the mean for one is 1.4 and the other is 1.7. But we don't need to know it because we have the z-score. Since 1.7 is higher, and we know that a higher z-score means higher away from the mean, that's a higher test score, that we know definitely that she did better in her psychology test. So the things that you need to know is the percentile is the percent of values less than or equal to a given value. And then z-score, it's the value minus mean divided by standard deviation. And the purpose is it's the number of standard deviations above or below the mean. If it's positive, it's above. If it's negative, it's below. The whole purpose is to compare values from different distributions using z-scores, just like I said about a man's height and a woman's height, or SAT scores and ACT scores. That's the same idea. In order to do these here, you can see finding the percentile. The percentile, again, it's less than or equal to. The Ohio one, if I count them, it is the 43rd piece of data, so 43 out of 50 is 86%. The next one, at the 52nd percentile, you just take 52% times 50 pieces of data, and that's where I got 26 from. Number 3, to do a z-score, you just, the value, which we found was 16 in Ohio, minus 8.7, because that's my mean, which it gives you here, and the standard deviation. And that's where I got this. How many counties does each state have? And so if you look at 88 counties, which Ohio has, and you find its z-score, you 88 minus 62.82 divided by 46.421, and that gets you 0.54. It asks you which one's bigger, which one's further from the mean. Well, if you look at the Ohio on number 3, that standard z-score was 0.751, and that's larger, so it's further from the mean. Okay, I hope that helped you, and we'll see you guys later.